Well, good evening, everybody, and welcome to Young, Gifted, and Wild About Birds. My name is Stephen Martin. I'm the Conservation Manager for the Connecticut Audubon Society, where I oversee restoration projects, manage and control invasive plants, as well as increasing biodiversity on our sanctuaries. I also oversee some of our seasonal staff and shorebird technicians over at Milford Point. Tonight's presentation will be the fourth Young, Gifted, and Wild About Birds of 2023. We have a increasingly large audience as folks start to trickle in tonight. So thank you everybody who is joining us. Before we get to tonight's speaker Mikko Jimenez, just a few notes for everybody. We are recording tonight's presentation. We'll send out a video link as soon as that is ready. Everybody will be muted for the duration of the presentation. And at the end of Mikko's presentation, we'll have time for a Q&A, so please use the chat for all questions. We also recommend that folks use speaker view from the upper right-hand corner of your screen. That'll give everyone a full screen version of the presentation. Closed captioning is also available if you'd like to use that. Now, let me introduce tonight's speaker. I'm super excited for this presentation. I hope everybody else is as well. Mikko Jimenez was born and raised in Chicago, in the Chicago area, and graduated from Knox College and currently lives in Fort Collins, Colorado. He earned his master's degree from Colorado State University and is now working on a Ph.D. there in the Aero Echo Lab, focusing on bird migration. He's also a former National Audubon Society employee, and his talk tonight will be focused on radar ornithology and how and where this technology can be applied. Mikko, thank you. It is awesome to have you here. I am super excited, and I'm sure everybody else is as well.
Thanks. Yeah, thanks so much for that introduction. Let me go ahead and share my screen real quick. Everyone seeing the right screen? Just make sure. Okay, cool. Yeah, thank you so much for that introduction. I'm really excited to be here today. You know, a lot of really incredible names, incredible scientists have been part of this series. Folks like Karina Newsom and Joanna Wu, Shannon Curley and Jose Ramirez Garofalo, Desiree Narango. So to be mentioned in that same kind of group of folks is honestly a really big honor. As was mentioned, I'm a PhD student studying radar ornithology. So that's what I'll be talking about today is just, you know, how we're using radar to study birds and in particular bird migration, where that technology kind of came from and where I think it's heading and some of the work that I'm doing. One of the things I want to kind of stress here is that I may be the sole presenter today, but I'll be talking a lot about the different work that's going on in my lab. So I'll be focusing on kind of some specific projects that people have done within my lab group. And, you know, I was new to a lot of this technology just, 2 years ago. And so I've learned a lot from my lab group. So everything that I'm presenting today is on behalf of the CSU Aero Eco Lab and my colleagues who are part of the lab. So whenever I talk about migration, I like to start with an image like this. So as was mentioned, I worked for the National Audubon Society on the Migratory Bird Explorer. And this was one of the products that came out of that project. This is a compilation of tracking data for different taxonomic groups. So land birds, raptors, shorebirds, water birds, and waterfowl. And the reason I really like this this product is just because I really think it blurs this line between art and science. From a science point of view, it's really helpful to frame migration by thinking about the scale at which birds are moving, right? Like birds are moving across entire continents throughout their full annual cycle. And so to protect them, we really have to be thinking at that scale. But then just from a personal perspective, I think this is a really cool way to think about how birds actually connect us to places we've never been, across the Western Hemisphere. For you folks in Connecticut who are watching from home, this is a really cool way to see along the Eastern Seaboard what types of birds are connecting you, to different parts of South America, all the way up into, the Boreal and into Alaska. It's a really kind of cool way to think and realize really that the actions that you take locally kind of resonate across this entire ecological system. And so that's like a spatial way of thinking about migration, but then also temporally, I think it's really interesting and also important to think about how we're just one, generation of many generations of people who have helped steward migration across North America. I am going to be reporting. I'm reporting here tonight from Colorado, and all of my research was done either in Wyoming or Colorado, which are historically the land of the Ute and Arapaho nations. But one thing that's really cool to think about is just locally, who have the stewards of wildlife been, where you live, and what is that kind of legacy? And one resource that I found that does this that has a lot of this information in one place is this nativeland.ca, where you can kind of look across North America and see, what indigenous peoples once lived locally or wherever you want to see across North America. And so I think this is, again, a really important way to frame the way we think about migratory birds is just the scale at which they use the land, and then also historically kind of our role as stewards of making sure they kind of make it across the landscape, efficiently and safely. And so some numbers to frame some of the ways that we think about this across the world, all bird species, about 19% of them are migratory. Here in North America specifically, we know that that number is about 70%. And so in North America, a disproportionate number of bird species are migrating. And that really colors, I think, the way that we think about protecting North American species, because we have to think about where and when they're going to be in different places. And that's a big part of how we approach North American bird conservation. And then of those that migrate, about 80% migrate at night. And from a science and research perspective, this is a huge challenge because birds, if they're moving, and at night, we can't really directly kind of observe those migrations. And so for a long time, this was a big hurdle in how we studied migratory birds. And so the point that I'm going to make today is that radar has been a really integral part of the way that we've learned about bird migration. And then more importantly, kind of connecting beyond birds, just connecting what we see on the ground to what is actually going on ecologically in the atmosphere. I think that has for a long time been a really big question mark in ecology. And that's what I really want to stress today, is that radar is becoming a tool that we're using to do that, to make those connections more explicit. And we're really lucky here in North America to have a system called the Next Generation Weather Radar System, or NextRad system. And it's a system of radars that were set up originally to monitor weather. So to monitor and predict where weather systems will be moving across the country. We have this series of radars across the continental US. And one thing that we've learned is that we can actually see birds using these radars. This was noted as far back as 1945 by David Lack and some of his colleagues, where they noted that you could actually use radar to see birds. Fast forward today, about 78 years later, and we have programs like Birdcast, which, if you're not familiar, Birdcast is a website or a project that seeks to create nightly bird migration forecasts across the continental US. And so this is a continental example of one of their forecasts, where you can see these kind of warmer colors are where more birds are moving through an area. So on this particular night, April 25th, 2022, there were a lot of birds moving through kind of the eastern part of the country. You can also see some of these light gray colors are precipitation moving through that part of the country. And then what's really cool about these forecasts is that they can be scaled down to a local scale. So for y'all in Connecticut, on this particular night, the number of birds moving through translated to these kind of lights out alert systems, where the western part of the state, there were a lot of birds moving through. And as I'll talk about later in the talk, this translates to some conservation action of making sure we turn off our lights so that they can pass over safely. So what I want to talk about today is just how we got here. Again, in 1945, we realized we can see birds on radar. In 2022, we have state level kind of alert systems set up, showing us where birds will be moving on a nightly basis. And so I want to talk about today how we got here. Specifically, I'll go over a brief history of radar ornithology. And then I'll talk about behind the scenes, how we actually make those migration forecasts for Birdcast. And then lastly, where are we going? So as a PhD student, I get to kind of this driver's seat, figure out kind of where I want to take the research that's new and exciting. And so I want to talk about some of the stuff that I'm doing and where I think the field is heading more broadly. And I hope to really get across that when you have this historical context of where radar has been, it really makes today where we are with radar ornithology a lot more exciting. So again, I'm going to go over a brief history of radar ornithology. I want to apologize in advance. I know that sometimes going over like a history lesson can feel, tedious or maybe, not the most exciting thing. But I really hope, what I hope to get across is that all of the cool things about birdcast today and how we're using radar ornithology today, it's been a really like a stair-stepping process of getting here. And so to prime some of this, let's first define what radar is. So radar is actually an acronym that stands for radio detection and ranging. And what it refers to is this process of using a station to emit electromagnetic pulses. And then those electromagnetic pulses bounce off of things that are in the atmosphere. And then some proportion of them are returned to that station. And then based on the waves of the pulses that we're getting back, the characteristics of those pulses, we can actually get an idea for how much of something is in the atmosphere, how big those things are, as well as, how quickly they're moving. And this is the basis of a lot of what I'll talk about today is this system of radar. And so this system is really based off of our understanding of electromagnetic waves. And so a lot of this idea dates back to the 1800s with this man here, James Clerk Maxwell, who first had this idea of, he predicted that radio waves would behave in these kind of wave-like fashion, and that in particular, light and radio waves were actually behaving the same way, but they just were operating under different frequencies. Later in the 1800s, Heinrich Hertz proved this experimentally by showing that light and radio waves actually behave very similarly, but that the frequencies are just different. And so you might recognize this last name, Hertz, because it's still the unit that we use today to refer to frequencies. This technology really took off, particularly across the military. There's a widespread military use of radar, and particularly during the Second World War, the first kind of broad application we saw for this was in the UK, where their Royal Air Force set up the chain home. Just given the geographic location of the UK, they were really, vulnerable to air strikes. And so the Royal Air Force set up this chain home radar system to alert them when there's aircrafts in the atmosphere, so that they can kind of, react to that accordingly. And one thing that was noticed, not just within this chain home, but across military use generally, was that there were these things called radar angels. And what these were the folks in the military were seeing kind of responses on radar, but they weren't seeing any aircrafts that were associated with those signals. And this actually frames that paper that I brought up earlier in 1945, where David Lack and George Varley, two British biologists, confirmed that these angels that they were seeing on radar were actually birds. And the way that they were able to confirm this was because they saw directly with a telescope, they saw northern gannets moving past the radar system and realized that it was, this was the signal that they were getting on radar. And so this was the first time that in the published literature that we saw, birds can show up on radar, and this kind of confirmed that. Pushing ahead to 1962, Richard Graeber and Sylvia Sue Hassler did a study using aircraft type radars to detect birds. I just really want to quickly note, like a lot of ornithology, a lot of the history of radar ornithology is older white men. And so seeing Sylvia Sue Hassler for me was kind of a cool thing within this history of just, some diversity within the history of radar ornithology in particular. And so what these two did was they set up an aircraft type radar on the building, on the top of a building in Champaign-Urbana. And they also set up a spotlight directly above that aircraft radar. And what they were able to confirm here was that what they were seeing on the radar screen, which is the right image that you're seeing here, was actually aligning with what they were seeing directly above them using that kind of spotlight. And so this was the first time, this is a big step because we realized we can actually use this technology not just to, one-off time kind of see birds on radar, but we can actually use it maybe to quantify birds as they move through the atmosphere. Because if what we're seeing is corresponding with what's being seen on radar, then maybe those two things, if those correlate well enough, then we can use that data. Pushing ahead to 1971, we get to Sid Guthrow, who is often regarded as kind of the father of radar ornithology in a lot of ways. And he used weather radar on the Gulf Coast to actually quantify arrival of Gulf Coast migrants, birds that were migrating across the Gulf of Mexico. And some really important context here is that at the time, there's a lot of speculation that birds were migrating across the Gulf of Mexico, but no one had really quantified that in any type of way. And so two really big steps here are that we're using radar at a regional scale, right? This is scaled up quite a bit from that Champaign-Urbana study. And then also we're starting to quantify the relationship, I think, between atmospheric conditions and bird migration behavior. You can see here that Sid noted these two kind of late arrival dates, or times rather, that on both of those nights there was rain at sunset. So we're making direct kind of comparisons or relationships between the atmospheric conditions and migratory behavior, which is kind of the beginning in a lot of ways of what we do when we forecast bird migration, which I'll talk about in just a little bit. Pushing ahead to 1979, Ron Larkin had the steady radar observations of bird migration over the western North Atlantic Ocean. And what he did was he used a mobile radar which was set up on a boat to quantify bird migration, or bird movement rather, across the Atlantic Ocean. And this has a special place in my heart, as you'll see in a little bit. I'm using a portable radar for some of my research. So this is just a really cool idea to move a radar around throughout the ocean. But two things that really came out of this study were he was able to quantify different waves of birds moving over. So rather than kind of a static, or not static, but a constant stream of migrants, what Ron Larkin and his colleagues were seeing was that migration tends to happen in these pulses, or these waves throughout a night. And another thing that this study notes is that oftentimes the direction that the birds were flying was correlated with things like wind, air, and ground, wind speeds and directions. And so again, here we're kind of quantifying this relationship between what we're seeing, the atmospheric conditions and bird migration behavior. So up until this point, we had kind of just been using raw data to, look at birds in the sky using radar. But there are a couple issues with this. And one of them is that radar stations will emit their electromagnetic pulses at an angle. And so what you get is this beam, this angled beam that's shining out, that's being emitted from the station. And because of that, we're shooting both below and under where birds are flying. So we're really just getting this cross section of the birds that are flying across the entire atmosphere. And so this is a problem because we know that there are more birds flying in the atmosphere, or flying over a landscape. And so the distance from the radar is actually a really big component of what we're actually seeing, the scans that we're actually getting back. The other big issue is that what we're getting back from radar signals is not a measure of individual birds necessarily, but rather reflectivity. And so this obviously is not a one-to-one, there are more, reflectivity is not in units that directly translate to the number of birds. And so there needs to be some type of kind of transfer or, calculation as to what the reflectivity and how that relates to the number of birds that are flying over an area. And so fast forwarding quite a bit, in the late 2000s, we had two studies that came out that really talked about this. One was by Jeff Buehler and Robert Deal. And both of these papers, the second paper was by Heiko Schmal-Johann and some of his colleagues in Germany. And both of these papers had to do with data calibration. How do we correct for distance, as well as how do we relate the reflectivity to the number of birds? And so these papers really developed these relationships, these mathematical models of how to correct for distance and how to relate the amount of reflectivity to the number of birds, or the amount of biomass at the very least moving over an area. And so a lot of this kind of came to a head in 2018 when Adrian Doctor and some of his colleagues at the Cornell Lab of Ornithology published this paper, Seasonal Abundance of and Survival of North America's Migratory Avifauna, determined by weather radar. And they used all 143 of the NextRad weather stations across the US, the continental US, to kind of quantify biomass both across spring and fall migration. And one of the cooler things that they found was that there was much more biomass moving during the fall migration across the continental US. And this actually makes a lot of sense intuitively when you think about the kind of the biology of bird migration. You know, in the spring, birds are moving up north to their breeding areas, maybe in the boreal or wherever. Then they fledge their young, and then all of those birds fly back down. And so we get more biomass flying down in the fall. So intuitively, you might think this, but to be able to confirm it using weather radar is the really exciting thing here, because it showed that this works. I want to give a quick plug. You know, this is a brief history of radar ornithology, but Rebecca Heisman just came out with a book yesterday called Flight Paths that kind of covers the history of migration research generally. And I just want to give a quick plug to that book. I haven't read it yet, but I've read some of the reviews. It looks like it's an awesome book. And just knowing Rebecca personally, I think it's going to be a great book. My advisor's in there. It talks a lot about the history of radar ornithology. And so I highly recommend you check this out if you haven't already, if you haven't gotten your copy. Okay, so that's kind of the history of migration, radar ornithology. I'd argue that a very big part of radar ornithology today is forecasting. And so, as I mentioned, I'm in a lab that's doing a good portion of this. And so one of the ways that this has come into fruition is through this project called Birdcast, which I mentioned earlier is a project that seeks to create nightly migration forecasts across the continental US. And it's a partnership between Cornell, Colorado State University, and UMass Amherst. And this really came to a head in 2018 again, when my advisor, Dr. Kyle Horton, as well as his colleague, Dr. Benjamin Van Doren, published this paper where they basically published the idea of using using radar to build a continental system for forecasting bird migration. And so the way that this works is it uses that NextRad weather radar station network that I brought up earlier. It uses all 143 stations. And if you go to the Weather Channel, or if you go to the National Weather Service, website, you might see something like this, right? I'm sure many of you are familiar with these types of images where you're seeing kind of weather patterns moving across the country. In this case, in the eastern part of the country, we're seeing these weather systems as well as some scattered systems in the Pacific Northwest. But what the National Weather Service works really hard to do is remove this. This is what we call bioscatter, and it's a measure of biological activity being captured by radar. And so as an ornithologist, this is the stuff that we're actually interested in. This is a measure of biological activity in the atmosphere at any given time. And so what we can do on the ornithology side of things is actually remove the weather, and what we're left with is the bioscatter, which we can use to then quantify biological activity in the atmosphere. And so this is the first step of creating a migration forecast. We take that raw radar data, we remove precipitation, and then we estimate the migratory activity for that night. This begs the question, though, that's historical data. How can we use those data to actually make predictions? And the answer here is using machine learning. We can produce algorithms that predict these types of things. And so that's what we do. We learn the associations with weather conditions. What this looks like on the back end is we organize these atmospheric conditions, these variables that can be used to predict weather or migration activity, things like air temperature, wind speed, air pressure, all these things that historically, all those studies that I talked about pointed to as being relevant for migration. And then we use machine learning to learn the relationship between all of those predictors the relationship between the predictors and migration activity that we're seeing through the radar data. So we use that to train an algorithm to make those predictions. Once we have that algorithm, we can test it using model evaluation, looking historical data, And then once we feel like we have a really good model that makes strong predictions, we feed it atmospheric predictions, and then it gives us a migration forecast across the continental US. And so this is step 3, is once we have a strong algorithm or a strong model, then we can use the weather forecasts to predict migration. And so it's I make it sound really simple, like this 3-step process, but this has been kind of decades in the making. And hopefully that history of radar ornithology makes it clear that each of those steps took a really long time to come into fruition. And so this is really cool from a science perspective, but how can we use this for conservation? I think there's a lot of really cool ways that we can do this, because if we know, again, where and when birds are moving, then we can actually take action to protect them. But one way that Birdcast has done this really effectively is thinking about light pollution. So we know, based on the literature, one of the folks in our lab, Dr. Carolyn Burt, recently did a review of the effects of light pollution on migratory animal behavior, and found, as many of you may know, that light pollution has a profound effect on migratory behavior. And particularly in birds, it tends to attract them to urban centers where they're more likely to collide with buildings, or be run into non-native predators, or just get stuck in these ecological traps. Well, if we know where birds are going to be moving across the continental US, then we can kind of target messaging to turn off lights on those nights when a lot of birds are going to be moving over the country. So on this particular night, April 25th, 2022, there were a good number of birds moving across the eastern seaboard. And so for that reason, we were able to connect that information to tell people to turn off their lights in places like Connecticut, which is kind of a really cool application, I think, of this information. And so this is one application from a conservation perspective, but I think there's also a ton of other, really cool conservation applications that we can use with this information. So I get a few kind of frequently asked questions every time I give this talk or I talk about Birdcast. So I'm happy to address these more when we get into questions, but I do want to quickly talk about them now, because I figure if I usually get these questions, people at home probably get them as they're listening to me talk. And so one question I always get is, does high activity mean more birds are going to be in my backyard the next day? This could be true, but not necessarily. I think one thing to keep in mind is that Birdcast and radar more generally is a measure of birds moving through the atmosphere. And so that does not necessarily mean that those birds are going to stop in these areas, like in the eastern, this doesn't mean that birds are necessarily going to be in your backyard. That's generally a function more of, habitat connectivity. And, if the conditions are such that the birds are going to move through an area or stop in an area. And so not necessarily is the short answer there. I also get this question, why do you show precipitation in these forecasts? So again, these kind of gray blobs are meant to denote precipitation. And that's to show uncertainty, because we can't always disentangle kind of biological activity from scattered storms with 100% certainty. And so there's some uncertainty associated with those areas. And then also some impacts on the biology of the bird or the behavior of the bird. High migration night coupled with low visibility from a storm system could mean more collisions. It can also mean things like fallout, where birds may be grounded for the night in a particular area. And so for those reasons, it just makes sense to show precipitation. And then lastly, how are the continental and state forecasts related? Sometimes it doesn't seem like these two things line up. And I think a really important thing to keep in mind here is that each of these maps is scaled to their extent. And so what that means is, for example, here in Colorado, a really high migration night here is going to be a lot lower than a normal migration night in a place like southern Texas, right? And so when we show these alerts, it's a high migration night within that specific region or that specific state. And so that's something that's important to keep in mind when you see those kind of high alert systems. Okay, so I've talked about where migration has been. I've talked about kind of where it is today and this forecasting system in Birdcast. But what I'm really excited about as a PhD student is kind of where are we going? And I think this is a really exciting time to be part of the radar ornithology community, because I think we're taking radar in a lot of different directions. I've talked a lot about forecasting in North America, and a lot of this talk is focused on North America. But radar is being used across the world for bird migration and bird movement. We work with a lot of colleagues across Europe and Asia, I just talked to someone at a conference 2 weeks ago who's using radar systems in Brazil to look at bird movement. And so geographically, bird forecasting and using radar to kind of look at bird movement generally is something that's really taking off across the world. We can also use radar to look at things that are not necessarily migration specific. So 2 folks in my lab, Maria Bellotti and Yuting Dong, have been using radar data to look at roosting behavior. It turns out if you look at specific times of the year, you get these kind of really distinct rings around different radars that denote kind of roosting behavior. And so because radar data go back decades, the NextRad system was developed in the 80s, I think the late 80s, we have decades worth of bird movement data. And so 2 folks in my lab, Yuting Dong and Maria Bellotti, have been using this to look at roosting behavior, which is a really cool application, I think. And then one thing that's really interesting to me is the idea of using radar to look at stopover. So if you kind of take a snapshot of birds early on in the night when they're taking off from wherever they had stopped over, you can kind of use that data to quantify where on the landscape birds are stopping over. This was shown in a paper by Emily Cohen a few years ago, this kind of technique for using radar to look at stopover. And that's something that really interests me. So radar's moving in a lot of directions. 2 things that I'm working on in particular, I'm working on a couple different things as part of my dissertation, but 2 projects that I want to talk about are validating and extending radar migration estimates using the BirdScan MR1, and the effect of urban land cover legacies on migration stopover. So this first project of validating and extending radar migration estimates, I talked a lot about, kind of in a brief nutshell, how we use radar to quantify bird, movement, but this all kind of assumed a flat landscape. But here in the West, where I'm reporting from in Colorado, it's a very mountainous landscape. We, at the very least, we're, here in the foothills in Fort Collins, and that kind of terrain can cause blockages in the radar system. So for this example, this peak of a mountain may be blocking off kind of half of that radar's the beam where it's looking at this particular snapshot in time. And so because of that, at a certain distance, the beam may be blocked and we may be missing biological activity or bird movement activity. And so what I'm really interested in is using a portable radar to kind of quantify the degree to which this is happening on a mountainous terrain. And so what I've been working with is this portable mobile radar called the BirdScan MR1. It was developed in Switzerland. And as far as I know, it's the only model, or it's the only mobile radar of this model that's in North America. And so what I've been doing is strapping up to the bed of a truck and taking it across Colorado to take data at different points away from a NextRad station. So I may take, one data point really close, one whole night close to the radar, and then move into a valley, take one up high up by Rocky Mountain National Park, and then one like way out there, 100 kilometers from the radar site. And my question is ultimately, to what degree do these 2 data sets correlate? To what degree do the data that we're seeing on the ground with the BirdScan relate to what we're seeing from the NextRad system? And then more specifically, if we understand that relationship, can we actually tweak the calibration process to improve NextRad estimates? So can we make the birdcast forecasting system even better if we understand this relationship with terrain? So this is a map of my sites. I have 10 different sites across Wyoming and Colorado. They both come to a point here at the Cheyenne NextRad station, and they're along 2 transects, one running southwest into near Rocky Mountain National Park in the mountains, and then one running southeast into the relatively flat landscape of central Colorado. And so that's what that looks like kind of in the central Colorado. It's relatively flat. You can actually see the light pollution coming from the Front Range, which is kind of wild. And it's, this is in Pawnee National Grassland, a really gorgeous place to spend a night. And then on the other end of the spectrum, this is one of my sites at 7,500 feet in elevation up in Estes Park outside of Rocky Mountain National Park. And so really very different sites here. And that's what my sites look like. This is what the actual kind of field work looks like on the ground, where honestly, we just drive the truck up. We have the radar in the bed of the truck, and we just kind of sit and camp, to be totally honest. The radar does most of the work for us. And then as the sun starts to set here, what we start getting on our mobile radar are these measures of what's moving through the atmosphere. And this, this level of detail is not something that we see on the NextRad radars. This is really specific to this mobile radar, where it has a classifier on the radar that's telling us, not only if it's a bird or it's an insect, but also what type of bird. So is it a passerine, or is it a wader? Is it a swift type? And so it's really a unique, really cool field season to be a part of, where I just get to drive this radar out into central Colorado and spend the night thinking about what birds are passing over me. And it's really given me an appreciation for the different landscapes that Colorado has. I think everyone kind of gets to Fort Collins and they see the mountains and they're kind of taken, by the mountains, which is great. And I think the mountains are really cool. But in particular, I've kind of fallen in love with the central plains of Colorado and the short grasslands, the shortgrass prairies, rather. This is a video taken by my research assistant, Annika Abbott, of one of the morning dawn choruses. We get hornlarks out there, as well as meadowlarks, and our state bird, which is lark buntings. Long spurs. We get mountain plovers out there. It's a really gorgeous landscape to be able to do my research in. And then the second project that I want to talk about is the effect of urban land cover legacies on migration stopover. So this was really highlighted in a paper that came out in 2020, and it's really this idea that's taken off across urban ecology. I'm an urban ecologist. I identify as an urban ecologist. I grew up, as was mentioned earlier in my introduction, I grew up in the Chicagoland area. And so I really like to think about how, cities function as ecological systems. And there's been this idea thrown out there by Chris Schell, in particularly in 2020, of how systemic biases actually play a role in ecological and evolutionary processes. And the framework that was set up here is this idea that systemic biases manifest themselves in these social processes, things like gentrification or a disproportionate, resource allocation, things like housing segregation and immigration policy. And those social processes end up having an effect on the impervious surface cover and urban heat islands. They have effects on kind of the structural characteristics of cities, which then, of course, have an effect on the ecological and evolutionary processes that we're seeing in cities. And so the prevailing kind of idea here is that environmental justice and social justice are inherently linked. And I wanted to bring one idea I have for my dissertation is to bring this idea to the concept of migration and migration stopover in particular, because we know that things like green space are going to correlate really, or are going to affect where birds are stopping over across a city. And so in my home town of Chicago, we know that one of the historical legacies of land use is redlining. It was essentially a series of policies that kind of put value on where you could kind of invest in real estate and the level of risk in investing in real estate across the city. And these policies had a pretty profound effect, both socially and socioeconomically. And today we see these kind of legacy effects of the distribution of different races and ethnicities, as well as things like personal median income. But in particular, it has this effect on the distribution of urban green space. And so my question is essentially, who stewards urban migration stopover? And to what degree is this tied, or has this been tied to discriminatory housing policy? If we know that these policies have affected green space distribution, then how has that affected kind of where birds are stopping over? And again, I want to use radar data to kind of quantify that stopover across the urban landscape. And so this gets back to my main point, which is that I think radar has been a really exciting tool to work with from the perspective of connecting us to the atmosphere above our heads. We're obviously terrestrial beings. And for the longest time in human history, we had very limited insight into what's going on above us. But we know, particularly for birds, that it's a very important part of their habitat, right? Obviously, the atmosphere is a very important part of where birds are using the different habitats across their full annual cycles. And so radar has been a really exciting tool for thinking about that and for connecting us to how atmospheric conditions impact what we see on the ground ecologically. And then zooming back out again, I want to get back to this point that, radar is one tool that we can use to study migration, but there are a lot of different technologies, as you probably heard as part of the series, that we can use to study migration. And it's a really cool thing to be in this migration research space where we're all learning from each other and kind of putting together different pieces of the puzzle one by one and seeing what lines up and what doesn't. But what becomes really clear from all of this migration research, I think, is that we're all really connected, particularly by birds, just because they move across these kind of huge scales, again, across the entire Western Hemisphere. And so it really brings home this point when you study migration, that the actions that you take in your own backyard or in your own kind of local green spaces, those resonate and those have an effect across this kind of huge ecological system, if through birds, if not through other organisms. And so with that, I just want to quickly thank again my entire lab, the Aero Eco Lab. In particular, I want to give a shout out to the postdoc in our lab, Ali Khaligafar, who I've worked really closely with on updating some of the birdcast models. And so those will be live at some point and part of Birdcast and integrated into Birdcast at some point. And if you want to follow that project, feel free to follow me on Twitter at Mikko Jimenez. And then from there, I just want to say thanks to all of you for being here on Thursday night. You could be doing so many other things. So the fact that you're here with me tonight is really a pleasure. And I thank you for coming. And with that, I'm happy to take any questions.
Mikko, thank you so much. That was very informative. And I think I speak for everybody that I learned a lot, and I think everyone did as well. We have some questions coming into the chat here. Michelle has been busy with questions, but we'll start off with one that I don't know if your research touches on too much, but you might have an opinion or view on it. What are the probable evolutionary reasons for such a high percent of North American birds needing to migrate compared to the rest of the world?
Yeah, that's a good question. And to be honest, my research doesn't focus on this too much. So I have a pretty limited insight into how or why that happens. I know that birds have been moving across North America and their migration has been really affected by kind of glacial retreat. And so I know that evolutionarily has had a pretty big effect on, and there is a lot of glacial activity, or has been a lot of glacial activity across North America. I think another thing, particularly in the continental US, is just geographically where we are. There's a lot of birds moving between kind of the northern boreal forests as well and into South America and Central America. So just geographically kind of where we are, I think, that's why we see a lot of migratory species coming through. I don't have as much, from an evolutionary perspective, I don't feel like I'm the person to necessarily answer that. Those are just kind of things that come to mind from things that I've read, but I don't think I have any kind of authority to think, from that perspective.
Yeah, no, my limited knowledge on that, I would tend to agree, it has to do with our the way that North America is set up, and a lot of birds are, especially in South America and other places in the world, are going, not necessarily needing to migrate based on whether it's mountain geographical conditions, available food, etc.
Yeah, no, exactly.
And then again from Michelle, how did you decide on the 2 test paths or transects for your mobile radar? And was it related to road access as well as correct terrain? And does anyone ever ask what you are up to when you're out there?
Yeah, this is a great question. Kind of all of the above. So we were really interested in two variables here. The distance from the radar was one variable of interest. And then also, as I mentioned, kind of the elevational kind of gradient. And so in order to test that, what we wanted to have was two transects, one that was relatively flat and one that was mountainous. And so we knew we were going to have one that went west and one that went east from the Cheyenne, Wyoming radar station. And then, so from there, we kind of distilled that down to, or we were guided rather by those logistical constraints that you talked about, road access, where were we going to be able to do this overnight? There was a point where I thought about having one transect run towards Denver. And then I quickly realized using all of that private land out there would be kind of a nightmare. And then also just running this thing in the city, I think, from one perspective, there's a lot of public outreach that can be a benefit. But then also, like just dealing with, people all night kind of asking what I'm doing, maybe not even with awesome intentions, or maybe from a perspective of just turn that thing off, it's really loud. And I have gotten questions, people have pulled over on the side of the road. People are, particularly in central Wyoming, it's pretty open country out there. And so if you're pulled over on the side of the road, people will, pull over and ask if you need help, if you're stuck there or anything. And people have often done that and then asked subsequently what I'm doing. And oftentimes I find that they're super interested and they have a lot of questions. And I always note, people always have an anecdote about migratory birds, or they always have a bird anecdote. And well, that's one of my favorite things about doing field research is hearing people's anecdotes. They always have, it's exciting to see the cranes moving over or something. And so when being able to show them that screen of the radar and how it's quantifying that the birds are flying over, they're always just they have their minds blown because they're so high up there that you can't even necessarily see or hear them, but the radar's picking them up. And so it's just one of those moments where you get to open someone's kind of ecological view of migration.
You are a steward of the migratory birds as well, so that's great to hear.
Yeah.
A question that's come up a couple times here is linked to wind turbines. So Jeremy Frost asks specifically at what altitude are the radars tracking the birds, and are the radar able to assess any issues that may be caused with wind turbine?
Yeah, it's a great question. So the specific radar I'm working with tracks up to 2 kilometers. Sorry, there's dogs moving here in the background, but it tracks up to 2 kilometers on the local radar. I'm so sorry, but I'm blanking on exactly how high up, but it's in that kind of ballpark range also for kind of the next radar data. And so, yes, I mean, at some level, we do know that we can use these data, just even from the birdcast forecasts to know where birds are going to be moving throughout the country. If there are a lot of windmills in that region, the same kind of idea applies here as urban areas where we can potentially, I guess, get involved or, take some type of conservation action. It's really lucky, or not lucky, but within the cities or within urban areas, we can kind of have that one action or that messaging, that clear messaging of turn off your lights. I think maybe the issue, and I'm not super involved with the wind energy issue, but I think maybe one of the issues there is just kind of there's a lot of different forces at play in terms of kind of maybe getting them to turn them off or, what have you. And so I don't know kind of what the clear messaging there would be or who you would message that to, but this is definitely a system that we could use to kind of inform those messages or that kind of messaging.
Cool, thank you. Another one from Michelle here. Is the removal of the precipitation from biomass data from the radar automated, or is that hand curated?
That's a great question as well. It is automated at this point, which is actually one of the ways that we've been, it's unearthed decades of data, because doing that by hand would be painstaking, if not, almost impossible to do at the decade level. And so it's automated at this point, but I think one of the cooler things, or one of the important things to recognize about that, is that machine learning only works when you have enough training data and ground truth data to feed an algorithm and train it. And so the reason it's automated today is because we had enough of that training data. And so there's a lot of human effort, I guess, that went into getting it to an automated process at this point.
So I have a personal question, and this is kind of going out of the nocturnal migration aspect of it. But do you foresee any radar use for predicting diurnal migration, such as like hawk migration based on weather patterns, et cetera?
That's a really good question. Yeah, I mean, I think the differences there might just be like, I don't know if we get as, and I could be wrong. This is kind of just me grasping at this, this isn't something that I've ever studied specifically, but my hunch would be that we don't get as strong of a signal or as strong as kind of these like huge pulses that we get when the birds take off, like nocturnally. My at least impression of a lot of diurnal migrants is that it's kind of like a, at least through the hawk watches that I've done, it's kind of throughout the day, they're kind of moving in these steady streams. And so from that perspective, you might not get as much of a signal, but that doesn't mean it's not possible. I'm sure there are ways that we could tweak that, tweak the system to kind of get at that. And especially as we get towards using, as we automate more processes and kind of have more tools to work with from a data processing side and from a data analysis side of things, I think that, yeah, that could totally be possible.
Cool. Yeah, no, that has always interested me, just seeing what we can see from the nocturnal migration as a hawk watcher. It's like, where can we predict these next big broadwing hawk movements in the country? Totally. Another one from Michelle, does reflectivity vary by bird species? You touched on this a little bit, but maybe elaborate if you can. Yeah,
this is a great question. And the reason so the local bird, the mobile bird scanner that I've been using, the radar that I've been using, the reason it's able to classify birds as wader types or passerns or swifts is because there is a difference in the reflectivity of the birds. What that classifier is actually doing is it's taking two characteristics of the reflectivity, both like the amount of reflectivity, so essentially the size of the bird, but then also the wing flaps. So because the target of the bird size changes as it flaps its wings, you get this kind of within the return pulses, you're getting kind of these secondary oscillations, I guess, of what are actually wing flaps. And so different birds flap their wings at different rates. And so when you combine that with the amount of reflectivity, that's what that classifier is doing. It's using those characteristics of the return pulse to classify it as a different type of bird. And so, yes, the characteristics of the return pulse do vary by different types of birds.
I have to imagine that it would be somewhat parallel to how like Fish Finder uses the reflection based on tail movement, etc., to potentially be able to identify which fish are down there as well.
Exactly. Yeah.
Cool. Well, I think unless anyone has any quick questions, that we peeled through the majority of them there.
Great questions.
Oh, here we go. If all goes well, how long until you finish your doctorate, and what do you plan to do?
Yeah, this is always the dreaded question amongst grad students, but I'm really hoping.
No pressure, man. No pressure.
Yeah. I'm really hoping to finish up in the next 2.5, maybe 3 years. That's my goal, and that's kind of where my trajectory is set right now. And then in terms of what I want to do next, I really liked the kind of nonprofit world, and in particular, kind of the nonprofit research and science world. And so that's kind of where I want to be. If I could find and another big part of that is I really like urban ecology. I really like living in a city. Again, that's kind of the environment I grew up in, and that's where a lot of my ecological questions come from, are kind of this interplay of city life and wildlife. And so I would really, yeah, those two things kind of combined. I'd really like to work for a nonprofit doing research, also writing. I really have enjoyed kind of writing about the science that I'm doing and communicating it. So if I could do all of that in a city, that would be my dream job. And so that's what I'm hoping to set myself up for through this PhD.
Awesome. That sounds very exciting. I wish the best to you on that. And one more quick question,
Sure.
and then we'll wrap things up.
Yeah.
In your experience, do you see that radar has any effect on the birds at all?
Yeah, not to my knowledge, right? So there's no reason to think at this point that the radar is affecting the birds. You know, particularly with the NextRad system, that this has been going on, you know, again, since the 80s. If there were, and there's also kind of like spatial distribution of like where these NextRad stations are set up. I think if that were true, we would kind of see that effect maybe differentially across those different sites. Like we have less of them here on the western part of the country. And so there's no direct evidence of this. And there's really no reason to think that this is a big issue for birds or that it's affecting them, as far as I know.
And I would have to imagine that the knowledge gained from using radar to predict these, you know, high traffic nights will offset tremendously any impact that the radar would have. But that's based just solely on my opinion here.
Sure. Yeah.
So it's a little.
Keep in mind, it's a good question to ask if you're doing more harm than good.
Absolutely. Well, there's a tremendous amount of comments thanking you for such a wonderful presentation and everyone wishing you the best of luck. But I do want to wrap things up with just a couple things to say. First of all, again, thank you for an amazing presentation. It was entertaining, educational. I learned a tremendous amount. Everyone else did as well. And we all look forward to referring to you as Dr. Jimenez in the near future.
Thanks for having me.
Next Young, Gifted, and Wild About Birds is slated for April 13th. It will feature Kathy Borgman, Ph.D. of the Cornell Lab of Ornithology. And then before that happens, in just a couple days here, March 20th, that's Monday evening, we're presenting a special screening of a short documentary called Mabel Osgood Wright, Pioneering Conservationist. Wright, of course, was a founder and the longtime president of the Connecticut Audubon Society. And as most of you know, this will be part of our 125th anniversary celebration. And the filmmaker Carol Evans will be on hand to introduce her film and talk about it afterwards. Everyone can register at ctaudubon.org/Wright. And just a huge thank you again. That was an awesome presentation, and really look forward to chatting with you in the future and seeing how all your effort progresses.
Yeah, thanks again for having me.
Thank you, everybody. Have a great night.
See you, everyone.